Thanks for clicking. Welcome to another Narmetry production. Today we're going to be talking about proving two lines are parallel using everything that we've done so far. Angles like corresponding angles, same side interior angles, alternate interior angles. We're going to use that now to go backward and prove that two lines are parallel. So you're going to convince me that it's true. All right, here we go. So let's take a look. Here's the idea behind this. I'm going to have my two lines again, the converse to corresponding angles postulate. So here's the deal. I have two lines. There they are. And I have my transversal. There it is. It makes those 8 angles, right, that we know so well now. Okay, so here's how this works. Let's call this line L. Let's call this line M. If two lines are cut by a transversal, so these two random lines, L and M, have been cut by that transversal, and the corresponding angles are congruent. So if you somehow know that the corresponding angles are congruent, I have to tell you that they're congruent. If I do, then the two lines that are going the same direction here, L and M, have to be parallel. So we're doing what we just did, but backward. So here's my picture. Let's say I had all my angles here. We'll call them 2, 3, 5, 6, 7, 8, 1, and 4. I don't know why I didn't skip 4 up here, but I did. All right. And let's say I told you you're given that angle 2 is congruent to angle 7. I'm telling you, angle 2 is congruent to angle 7. I know that. So now take a look. Angle 2 is in the top left corner. Angle 7 is in the top left corner. Angle 2 and angle 7 are corresponding, right? Now, they're corresponding. And I also know, I told you, hey, these are congruent. Since the corresponding angles are congruent, I'm telling you that, then we can conclude that line L is parallel to line M. These two lines have to be parallel because the two, angle 2 and angle 7, are corresponding and they are congruent. Now let me show you what doesn't work. Let's say I were to tell you that angle 3 is congruent to angle, 7. Now you look at this picture here. Angle 3 is in the top right-hand corner. Angle 7 is in the top left-hand corner. Angle 3 and angle 7, they're not corresponding. Since they're not corresponding, you can't say that L is parallel to M. 3 and 7 are congruent, but they're not corresponding. Since they're not corresponding, you can't say the two lines are parallel. Okay, you can only say these two lines are parallel if I give you, for example, two corresponding angles that are congruent. All right, but it also works with the other sets of angles as well. Let's say you had two of your lines cut by a transversal, and we'll label up our angles here. 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Let's say you were given angle 5 is congruent to angle 8. So take a look. Here's your lines going the same way. So this is your interior, right? The other 4 angles are on the exterior. Okay, angle 5 is on the exterior on one side of the transversal. Angle 8 is on the other side of the transversal on the bottom on the exterior. So angles 5 and 8 are alternate exterior angles. And if alternate exterior angles are congruent, then the two lines are parallel. So if we call this line L and line M, then we can say L is parallel to M. Those two lines are parallel to each other. Okay? It also works with alternate interior angles. So if I give you, let's say angle 1 is congruent to angle 2, well, these are alternate interior angles, right? They're in the interior, alternate sides, okay? They're alternate interior angles, 1 and 2, and I told you they're congruent. Then L is parallel to M. You can make that conclusion. All right, so it works with alternate interior, alternate exterior also. And of course, it works with same side interior also, but you have to know the rules for same side interior, SSS. Same sides have to be supplementary. So let's say I labeled my angles here 4, 5, 6, 7, 8. All right, here's my interior, right in between the two lines. And let's say I told you, given the measure of angle 3 plus the measure of angle 4 is equal to 180. Well, angle 3 and angle 4, they're both in the interior on the same side. So they're same side interior angles. Same side interior is supposed to be supplementary. So I said that they are supplementary, right? The two angles add to 180. Then we could say L and M are parallel. What if I were to give you and tell you the measure of angle 1 and the measure of angle 3 is 180 degrees? Well, let's look at angle 1 and angle 3. Angle 1 and angle 3, they're both in the interior. They're on opposite sides of the transversal, but they're not alternate interior, right? 1 and 4 are alternate interior. And they're certainly not same side interior. 1 and 5 are same side interior. So are 3 and 4. Okay? Angle 1 and angle 8, they're a linear pair, right? These two angles form this blue line here. Okay? 1 and 3. They form the blue line. But that's not any of these other relationships. They're not same side interior. They're not alternate interior. So we can make no conclusion. We can't conclude that the lines are parallel because we're not talking about one of the sets that we know. Corresponding, alternate interior, alternate exterior, or same side interior. These are just a linear pair. That doesn't help us to make the conclusion that the lines are parallel. All right. So now let's take a look at an example here. Here we go. Given the picture at the right, explain which lines, if any, are parallel and why you know they're parallel. Okay, so here's our two lines going the same direction, J and K. J, and there's K. And then here's our transversal through it. Okay, let's take a look. Let's take a look at our angle pairs that we have here. What's congruent, and will that help us? Angle 2 and angle 6. Here's angle 2, top right. Here's angle 6, top right. They're corresponding. The corresponding angles are congruent. So J has to be parallel to K. That's the rule. If the corresponding angles are congruent, then the lines are parallel. How about 3 and 6? 3 and 6 were in the interior between the two blue lines. 3 and 6 are alternate interior. Alternate interior angles are congruent. So we can conclude that J is parallel to K. 1 and 8. 1 is on the exterior, top left. 8 is on the other side of the transversal. They're alternate exterior angles, and they're congruent. So alternate exterior angles are congruent. So we can conclude J is parallel to K. 3 and 7. 3 is in the bottom left of this pair. 7 is in the bottom left of that set. Yes, they're corresponding. Corresponding angles are congruent. It says that 3 is congruent to 7, so J is parallel to K. Look at 4 and 5. 4 is in the interior. 5 is its alternate interior, and it says 4 is congruent to 5. So alternate interior angles are congruent. So J is parallel to K. We can make the conclusion. Now look at 3 and 4. Well, 3 and 4. 3 and 4 are both in the interior. It says they're congruent. 3 and 4 are both in the interior, but they're not alternate interior. Okay? They're not alternate interior. They're not alternate interior angles, so we can't draw a conclusion. No conclusion. We don't know if these lines are parallel based on 3 being congruent to 4. All right, and that's it. Basically, what we're doing is we're taking what we did in the first 2 sections and trying to reverse it. Okay? As always, thanks for clicking.